Hey, I'm Phil McCaffrey, and welcome to 8:30 Prep. It's Thursday night, and the world is canceled, so nothing is happening in the entire world. Teo, do we have any viewers? Anybody watching at all? Concurrency. Four people watching. All right. Hi, four people out there. Hope one of you is Gavin. This is the last day of Systems of Equations. I'll be making playlists of all these videos. One of the things that I've been doing is playing with the math. And starting next week, we're going to try something new. We're going to have a little Zoom with my partner, David Cerniglia, who those of you who've tutored with me know David is the grammar king. So check out Facebook and Instagram for a meme of David Exotic as the grammar king. So today, without any further ado, we're going to talk about systems of equations, word problems. And let me back up for a second here on the board. Systems of equations, word problems is something that is a standardized test prep question. It appears quite often. And what happens is they give two things. Let's call it apples and oranges. And they give the total number of the things. Sometimes they give us variables, as we've seen this week. Number. Look how I spelled number. Isn't that beautiful? Total. That's a beautiful thing there, Teo. Number. Total number of things. So you take the two variables and you add them together, or three variables, as we'll see tonight, and you add them to get the total number. And then sometimes there's a value. Okay, so that would be the price of apples and the price of oranges. So let's say apples are $4 and oranges are $3, and the whole thing together is worth so much money. So what you have to do is set up a systems of equations from the words that they give you. And the best way to do this is practice. I have lots of worksheets on them. I have many examples, and I just picked out a few for tonight to go through on 8:30 Prep, as well as to send this out to students later when they're studying. So let's go through it. Here's an easy off of the ACT. I think tonight is mostly ACT. I was going to go through some old SATs. We did SATs. They like to give the equations as the answers or something like that. But we had some inequality word problems from the SAT. So this one is a number 5. It says the sum of two numbers is 90. They don't give us the two numbers, but what do we all love? X plus y. So the sum of the two numbers is 90. The smaller number is 50 less than the larger number. Let's make x the smaller number. Is an equal sign. 50 less is y minus 50. Okay, it's 50 less. Sometimes a student will write 50 minus y. Maybe we should do that problem and see if that answer is there. And then we substitute it in. We can just take this up here and put it in. And we get y minus 50 plus y equals 90. Let's add 50 to both sides. I get 2y is equal to 140. Y is equal to 70. That's the larger number. Let's do this backwards. Let's do x is equal to 50 minus y. And if I substituted that, y's would cancel. So it's a number 5. I can't do that. Sometimes they do that. All right, let's take a look at the next problem, problem number 6. So one of the reasons why I want to teach this is for speed. I have students do easy problems, do them very, very quickly, and do things that I call suicides, and that's to take off my test bank old ACTs. As we all know, the old ACTs are called TIRs. And you do a bunch of the easy problems really, really quickly. I call them suicides because it's like running for a sport when you're sprinting and you feel like throwing up afterwards. This gives you time to do the harder problems. As we saw last night, we did some harder problems on systems of nonlinear equations. All right, here's a classic. The ABC Book Club charges a $40 monthly fee plus $2 per book read in that month, and the Easy Book Club charges a $35 monthly fee and $3 per book. It's a stupid problem because nobody would pay a book club $40 a month, but we all know it's just made up numbers. So it's $40 plus $2 per book. We'll use B as our variable. For each club, how many books must be read, and what's that?
How original.
How original. I like to use the letter of the thing they're using. We could have thrown an X. Some students have to use an X. How many have to be read in 1 month for the total charges to be equal? Read with your pencil. So then we get 35 is the base fee plus $3 per book. One of the things you can do here if you're struggling with mathematics is just simply put in the answer choices. And you can see that 75 is ridiculous. That just won't work. We could put in 6. 42 plus 2 times 6 is 52. 35 plus 3 times 6. Does that work? Is that 6? 18 and nope, it doesn't. But let's solve for it anyways. The answer is 5. 10. Yep, the answer is 5. I did it in my head. This is one that you should practice in your head a little bit. So let's do 40 plus 2 times 5 equals 35 plus 3 times 5. And we get 40 plus 10 equals 35 plus 15. And 50 equals 50. The answer is 5. So it's good to practice plugging in or back solving the answers as a technique, as well as doing the algebra. This is one to practice both ways. All right, here we go. TV. The Uptown Cable TV provider charges the customers $120 for installation and $25 a month. Wait a second. This is the exact same problem as the one before. I could make this up all day long. It's a service fee. It's a linear function, a flat fee, plus a rate. So it's y equals mx plus b. So we have $120 plus $25 per month is equal to $60 plus $35 per month. And then we can plug in the answer choices, 10, 3, 6. Let's solve this one algebraically. Let's subtract off 60, and let's subtract off 25, and we get 10, and the answer is 60 over 10, or 6. So we could practice this one algebraically, or we could plug in 6. Let's plug in 6 and do 120 plus 25 times 6 equals 60 plus 35 times 6. So back solving using the answer choices and algebra both go both ways. All right, a number 15. This problem is off of the 2015 official practice test. I do this problem at least 6 times a week because students really get screwed up. It's a number 15, and it says Cami sold 70 figurines in 2 sizes. Large is sold for 12 and small sold for 8. So small plus large equals 70. This is the setup on almost every single one. The amount of money he received from the sale of large figurines was equal to the amount of money he received from the sale of smalls. So $12 times a large is going to equal $8 times a small. Where do we put the equal sign? Was equal to. This is the value equation. How many large figurines? We're going to solve for large by substituting smalls. So small equals 70 minus large. Let's substitute this down here, and I get 8 times 70 minus the large. 12 large equals 8 times 70 minus large. This question asks 7 times 8, which is 56. 560 minus 8 large. Let's add this to this side. We get 20 large. And now I have to divide 560 by 20, which is 56 divided by 2, which is bigger than 25. And that's going to be 28. It's not 35 because 35 times 2 is 70. So that's too big and 20 is too small. So 28 is the correct answer. Let's plug that back in there and see if 28 times 12, okay, that is 336. I've never actually checked this problem before. And 70 minus 28 is 42 times 8 equals 336. I've actually never done the math to see how much money old Cami earned. He earned 336 times 2, which is $672. So that's another way to write this problem. All right, getting into a little bit harder, but the same setup. Now it gives us a table, and this was a table that had multiple questions with shampoos and haircuts and all kinds of things. And it says the table below gives the prices for dog grooming at Pretty Pooches. The size of the dog is a small or a large. There we go again, smalls and large. And Huakua, I don't even know how to say this. This is one of the things that comes up is the names, and particularly in the science, is words you don't know how to say. I wanted to, this morning, sit down and look to see if there was a website where I could pull up foreign names to throw into word problems. But since I steal all of my material from the publisher, I really don't need to write my own problems. So whoever this person was, they brought in 10 dogs. So small plus large is equal to 10 dogs. That's the count of the dog, the total number. So what's the value? The value is $260 is what he paid to have them all shampooed. So it's $20 times the small plus $35 times the large equals $260. How many large dogs? We're going to solve for large by substituting 10 minus the large in for the small. Let's change colors and say 20 times 10 minus large plus 35 large. Hey Alex, how you doing, buddy? Is 260. Keep studying, get some money for college. Let's distribute this 20 and get 200 minus 20 large plus 35 large. Oh, we're getting to 15. Stop right here. I haven't solved this problem. I saved it for tonight. This is going to be 60 divided by 15, which is 4. They love this. I pointed this out earlier this week. No 15 times 4 is equal to 60. This equals 260. I subtract the 200 off, 20 off of 35. Yep, 15 large equals 60. Large equals 4. Small equals 6. So we have 6 small. So let's do 20 times 6 plus 35 times 4. And that gives us $260. We've done our work. I wouldn't actually go that far and check it when I was taking the ACT for real unless I had extra time and I wanted to go back. I would get the right answer and move on. All right, here's a multiple stage translation problem. This one is really a standardized test problem. Nichelle Mabel has 84 solid colored discs that are either red, blue, or green. She lines them up on the floor and finds that there are 24 more red discs than green and 15 more green discs than blue. Okay, so red, blue, and green. She has 84. So R plus B plus G, Ruth Bader Ginsburg, equals 84. Let's do this 24 more. So there is 24 more red. So red is equal to 24 plus green. And green is equal to 15 plus blue. We have to do a lot of substitution here. How many red discs? So we want to keep this red and we want to replace the blue and the green with red. Green is easy. That's red minus 24. So we have 1 red plus red minus 24 equals 84. So let's take green is equal to red minus 24 and then subtract 15 off of that and get 39. So blue is red minus 39. I'm going to now add 39 and add 24 to 84. Let's do that one on the calculator and let's go 84 plus 39. Was that correct? Plus 24. I haven't done this problem yet. 147. Okay, 3R equals 147. What I was checking to see is if that the sum of the digits of 147 was a multiple of 3 to see if I made an arithmetic error. 147 divided by 3 is 49, and that's an answer choice. Let's check our work. 49 minus 24 is 25. And 25 minus 15 is 10.
Like, better not use that calculator.
I better use the calculator. I tell my students your calculator is better arithmetic than you are, so doing it live online sometimes sucks. So let's do 10 plus 25 plus, what do we solve for? 49. Geez, I couldn't find my answer. 84. Works out well. So the right answer is 49 red discs. I don't really like that green color. I like blue and purple and red better. All right, here's the last one for the evening before we finish up, and it's a number 57. Two numbers have a product of negative 48 and a sum of 0. So x plus y is equal to 0. The sum is equal to 0. That means that one number is the opposite of the other. So x is equal to negative y. So this is the square root of 48. So x times y, they're the same value, they're the same absolute value. So what this is asking is the square root of 48. And when it's the square root of 48, I see the square root of 3 and the square root of 2 in here, 4, 3, 2. So what it's taking out is 16, 9, or 4. 48 is not a product of 9, so B is wrong. It's certainly not 0. What is the lesser of the two numbers? The sum of 0. 0 plus 0 is 0. That doesn't make sense. And 3 plus negative 3 is, that can't be the lesser number because the greater number would be positive. So two positive numbers that multiplied together would not give me a product of a negative. So what I have to take out of here is 16. So we're going to do 48 divided by 16. Another good number to know, which is 3. 3, oh my. 3, yeah, times the square root of 4. 4 times, yep. The lesser number is 4 root 3. The greater number is 4 root 3 positive. The lesser number is this is y, this is x. If we multiplied them together, let's do quantity 4 times the square root of 3 quantity squared. Enter, 48. There we go. It's a great one. All right, that was it's 8:48. How many minutes is that? About a half an hour. 28 minutes. 28 minutes is not bad for systems of equations next week. Oh, did you post up the meme of the week? It's 18 minutes. It's 18 minutes.
Come on, man.
I can't do math at all. I am a math teacher, can't do math. I'm looking at the 48 and can't subtract 30. I want to keep these under 20 minutes is why I've got 850 on the brain. It is under 20 minutes, which is a great lesson on system of equations word problems. All right, next week, get the meme of the week up. We're going to have David Cerniglia, the Grammar King, on. We're going to do grammar on the ACT. And next Thursday night, I'm going to work on a special one, which is I pick out things that are almost always wrong. I hope you look forward to next Thursday night on 8:30 Prep. I'll see you then. I'm Phil McCaffrey. Take care.